Hello everyone and welcome to my tutorial series. My name is Bryce Franzen and we're going to be starting the Python for Everyone tutorial. It's not a waste of time, let's jump right into it. We will first be starting in the Google Colab. You can just look up Google Colab to do this. It's the easiest, especially if you're getting ready to start, because you can see what's happening as you're coding, test different things, and it's just really good for anyone new or anyone even exploring a new library. So the topic for today is going to be data types. But before we get into that, let's show how we can kind of organize this Google Colab code so we can make sense what's going on and also come back to it later. All we're simply going to do is hit the text. We can, if we want to move something up or down, we can go like that. Double click to enter any of your text or code. So let's double click the text. Google Colab essentially uses headers where hashtag is the main header, double hashtag is a header under that, triple hashtag, and so on. So first, because we're just kind of starting out, we're just going to say hashtag data types. Now, if you want to execute that code, well, it's not really code, but text. But if you want to execute code or show text, you can just simply do Shift, Enter, and it essentially runs it. Now, if we want to do another heading, as we said, add text, do two hashtags this time. And first, we're going to be starting with the string. Now that that's for the most part out of the way, we're just going to go over the main data types that are in Python, which include the string, int, the float, dictionaries, lists, boolean, and so forth. But we're going to keep it as simple as we can, and let's get started. So if we want to have a string, all you're simply going to do is you can either use single parentheses or you can use double parentheses, and you put your string text inside those parentheses. Now, we could just do something like hello, run it. Google Colab may be slow at times, especially if you have a ton of notebooks open, but it might get over that, we'll see. As we can see, prints out just our string, hello. But even more important than that is to actually set a variable equal to that string. And that's just as simple as saying something like, my variable equals hello. And hit enter. Now we have my variable, which is set equal to the string of hello. As we can watch this. Shows us our variable and gets us our variable. Now, if we wanted to print it out, just what's basically inside of there, we would do something using the print function. We're just going to say print, and we're going to pass in our hello variable. You can see, just prints it without those parentheses, because it's just, or the apostrophes, it's just hello. Now, let's say we wanted to print a string itself, we can do that as well. Let's say hello world, shift enter, does it again. Now, let's get into the important methods that come with string. One method is to just get its type, and we can do that for any of these variables that we're going to talk about today. So let's just find out the type of our my variable. Simply do type, and then essentially what you're doing is you're passing, type is a function, and you're passing in the variables to the parentheses, which is essentially your input, and it will return to us its type. So let's just pass in that my variable. We see, just like we thought, it would be type string. Now, what if we wanted the length? Let's say someone's name. So my name is Bryce, and we want to get the length. So we do length of name. You can see returns 5 because there are 1, 2, 3, 4, 5 characters. Now, what if we wanted to index and grab certain characters out of there? We can do something like this. You're essentially indexing into the string, which is all in all just really a list of characters. So if we wanted, let's say, the R, we could do name 1. And one thing to keep in mind too is that the list starts at 0. So B, name 0 is going to be B, name 1 is going to be R, and so on. So let's get that R. Look, returns us the string or the character for R. Now, let's say that we had a name that was not capitalized, but we want it to be capitalized. Let's first set that uncapitalized version. If we want it to be capitalized, we're simply going to do name and then run the function on it, dot capitalize. You can see we have a capital B now. Another one we could use is name dot upper if we want it to all be uppercase. Another option we have to do is, of course, the lowercase, name dot lower, which really in the end is just going to get us what we already had for it. Now, one important thing to note is that when we are running this dot upper or dot lower, dot capitalize, it's not really changing the actual string value. It's just returning us the value after it's been uppercase or lowercase, like that. So if we want to actually change the name variable itself, we would do something like this. We would say the name, we would essentially just reassign the variable. Name equals name dot upper. Okay, we did that. Let's see what name gives us. Okay, now it gives us our full uppercase. And just to show an example of how you cannot, or how it doesn't save the variable unless you actually redeclare it, let's do something like name dot lower. Okay, yes, we get the lowercase, but the name variable itself is still all uppercase, as we kind of explained. Now, moving on to a couple other things we can do with string, we can actually do addition, where it essentially just appends the strings together. Let's show an example of that. Let's say my first name equals Bryce. And let's say my last name equals Franzen. Now that we have those variables, we can get a full name equals, it's just simply first name plus last name. Let's print the full name. As you can see, it just adds them together. But we can see that, okay, we probably want a space in there. So let's take care of that. Instead, we can say full name equals Bryce, or equals first name plus, and we can actually directly put strings into here as part of this addition as well. So let's just do that. We have, this is essentially just a string that is a space in between the first name and the last name. Then we'll go ahead and print the full name. We can see that there's now a space in between there. All right, we're starting to get somewhere. Now, what if we wanted to replace something? Let's say that I entered in my first name wrong and my name is actually John. We can do something called replace on the string. You're simply going to take the string, which is now just full name. We're going to go dot replace. And let's replace where it says Bryce. Now it is case sensitive, so keep that in mind. And let's replace that with John. And remember, I almost forgot, we have to actually set the name and hit enter. And we can print out and see what that gives us. Look, John. Now, if we move on from there, we can look at how to essentially split a string based on characters that are inside of it. Let's say that we had a string that was just a list of fruits. Let's say fruits. It's really a string. It's not quite a list yet. Equals, say apple, banana. I don't know. Hopefully I spelled that right. Doesn't matter. and orange. Now, okay, we're not doing list yet, so we're going to keep them inside of their own string. You can see that. Okay. Now we notice that we can do fruits dot split, and we can pass in what we want to split by, which will be the comma. And let's do that. Okay, it's split up by comma, and so that essentially returned us a list, which we'll talk more about later. We can also do something like, let's say that it was an exclamation mark in between them. We can do that as well. Equals apple, banana, orange. And let's split by the exclamation mark. Look, you get the same exact thing, just as we expected. Now, just a couple small other things you may run into or want to do is if you have a bunch of space characters, let's say inside of your string, we can easily get rid of that. So let's first make the string. Let's just call it example string equals 1, 2, 3, 4, 5. Let's say it just has, it could really be any number of spaces. I just put 5 here. Let's say some text, and let's do another couple, just random number of spaces, doesn't really matter. From that, well, first let's just run it to make sure that stays the same. We can just simply run strip on it, and it will get rid of both this side and the empty characters on this side. Let's go example string dot strip. You can see that. And now, of course, remember that it did not actually change our string itself, as you can see. Still have that, so we can still work with it. Let's say you wanted to just strip the left side. Just do something like this. Example string dot L strip. And that's going to strip the left side empty characters or spaces off. And of course, you can just do the same thing to change L to R if you want to strip just the right side. There you go. Now we've covered most of the string. It'll make more sense as you work with it more and more. But now I think we can move on to actually doing the integers. So let's do that. We'll call that integers in our text. Now, let's just, just a general breakdown of integers is that they are whole numbers, such as 1, 2, 3, 4, etc. You get the point. There's no decimal places is the important thing to remember. Let's do an example. Int example equals 10. Okay, now our variable int example is equal to 10, which is an integer. And we can prove that by doing the type function we explained earlier. Look, type int. Now, let's say we wanted to convert that int into a string. We can say string example, and now the name doesn't really matter. This could be anything. Let's just call this another example equals. All we're simply going to do is pass our int into the stir function. So let's do int example, and then to make sure that worked, we can do another example, get the type of it. Okay, it's a string. And we can also see it did not manipulate our old one either. So if we do type of int example, that one is still an int. So that's of course important to remember. If we wanted to actually change the int example variable itself, we would just change another example to int example, and it would do that for us. Now we can just do basic mathematic operations on our integers, such as, let's say, just integers at first. Let's do 5 plus 5. You get 10. Now let's say example 1 equals 2, and example 2 equals 5. We can also add these variables together. You can see we get 2 plus 5 is equal to 7. Okay, that's great. What if we wanted an easier way to add on and also redeclare at the same time? We're just going to do something like this. We say example 1 Now you're going to say plus equals 2. So it's going to actually change our example 1. It's going to take what example 1 is, add 2, and then redeclare the variable to the result. So example 1, since it was equal to, okay, look, 2 first, and we wanted to add 2, it'll equal 4. So let's see that that works. Okay, we got 4. And you can really do this with anything. You can say minus equals 2, you can do times equals 4, you can do divided 2.0. Okay, now this is important. This kind of leads us into our next data type example. Whenever you're doing any division or anything that's, let's say it's a float and an integer, and you're doing an operation on them, it will always return what is called a float data type. So floats, just simply they're decimal places, and it's honestly better to work with floats when you can, just in case, to stay consistent. Let's do an example. Let's say float example equals 2.5, and let's see what type that is. Okay, it's a float, just as we expected. Can do basically everything that we did with integers, we can do with floats. So if we wanted to say float example 2 equals, let's say it's 3.2, we can add them together. Let's just call it result equals float example plus float example 2, and let's get that result. 5.7. So you can see that worked to add the floats together. Now, let's say with the integers that we had an integer and a float in our operation. So let's just redeclare the int example equals 5. Remember, no decimal places. You can say float example equals 2.5. Now the result equals int example plus float example. And we can see what that result is, 7.5, so that worked. Now what about that type? Let's say type of result. Look, it's a float. And now even if, let's say that our float example was 2.0, you would think, oh, okay, so it's going to be equal to 7, which you're like, okay, maybe that's an integer, maybe it's not. But because we use both a float and an integer, it's going to still return a float. Kind of has to do with the significant figures, if you've ever done with those. So let's just say, add those again, get the result. Okay, 7.0, get the type of the result. Well, it's not type of the result, it's the type of the variable that result represents. Float. Okay, there we go. Now just a couple other small things we can do with float is we can actually round. So let's say pi example equals 3.1415. Okay. And if we wanted to round that, we would essentially do rounded pi equals, we would just simply call round. And then in that function, we're going to both pass in as the first variable what we are rounding, which is pi example, and we want to say how many decimal places to round to. So let's just say 2, and print that out. Rounded pi. 3.14. You can see it did that just as we expected. Now, let's say if we were wanting to print it out and also do a decimal place or insert a variable into our print and adjust its decimal places. Kind of kill 2 birds in 1 stone here. Let's say print. You can use what's called an F string. There's other ways that you can do this, but the F string is by far the easiest to understand and what I recommend you guys do. So you're just going to say F and then the string. Okay, now we have our string or our F string. Let's say we can just write any string or normal text in here. Our rounded pi to 2 decimals is, and you're simply going to put the brackets, and inside these brackets you can use any Python variable. Let's say pi example, or let's actually do rounded pi first. Look, it says our rounded pi to 2 decimal places is 3.14. Now let's say that we actually wanted to do this all in one go, essentially pass in this pi example and round it already in here. All we're going to do, print f, let's say our rounded pi is, you're just simply going to pass in the pi example, and then after that you're going to do colon dot 2f. Now what does this 2f mean? It means that we're going to do to 2 decimal places and return it as a float. And now just hit enter and it should work. All right, we did it in one example. There we go. And small, we'll also talk just slightly about the scientific notation, since this channel kind of is more directed towards using Python for data science. Let's say we have a number that is equal to, I don't know, 1, 2, 3, 4, 5, 6 dot, I don't know, just any decimal places. If we want to get that in scientific notation, just simply use our f string again, and we're going to do number, and then instead of dot to f, we're going to do dot to e. So it's going to be the 2 decimal places and in scientific notation. All right, there we go, we got it. This leads us on to our next data type, which is the boolean. Let's say that. Boolean is just simple true or false. That's really all it is. There's operations we can do on it, but at the base or end of the day, a boolean is a true or false. And these true or false are set by saying capital T, true. You can see it's blue because it's a special type. And notice there's no print or apostrophes around. Also do false. You can also see that's blue. And we can also set it equal to variables. Let's say example bool equals true. Get its type just like as we've always done to prove it. You can see it's a bool because it's a true or a false. Now we can do operations actually on these booleans. Let's say example bool, or let's actually do this. Let's say example1 equals, we can literally pass in if we want an int, a string, anything like that. Let's just do a string for now. Hello. Let's just create another example2 equals, let's say that's also hello. And let's also create one that is example3. Let's have that be goodbye. All right, now we have our variables. You can even see that they are actually type string. However, we can get booleans out of these by doing something like this. Let's say example1 equals, instead of doing a single equals, you do a double equals to say, as basically equality, is it equal to example2? Are they the same thing? True, because they're both hello. Now, that makes sense. Another important thing that we can do just to make sure that the types are the same, like let's say that we had, I don't know, let's call this example4 equals 1 or 10, I guess, and example5 equals 10. But this time, instead of 10 as an int, which it is here, it's going to be 10 as a string. Now let's do what we just did. 4 equals example5. You can see false, because they are of different types. Make sure to keep that in mind. If we wanted to first convert that to a string or an int, we would just do this instead. example 4 equals, instead we're going to say int equals equals int. We're going to pass in that example 5. True, because now they're both ints equal to 10. Now let's do an example where it might be equal to false, where example 1 equals example 3. False. Of course that's false because the strings are different. Now what if we wanted to say that they're not equal? Example 1, instead of equals, say exclamation mark equals example 3. Now think, what might that return to us? True, false? Think about it for a little bit. Okay, now that you've thought about it, since we're saying example 1 does not equal example 3, it's essentially taking this whole expression and seeing if that's true or false. So let's do it. True, because it's true that example 1 is not equal to example 3. That makes sense? Okay, let's move on to boolean still, but using ands and ors so we can get longer, essentially boolean statements. Let's say example 1, let's say that that's equal to example 2, which we essentially know that's true. We're going to use the special and keyword. Example 2 equals, or let's actually do example 1 equals example 3. So we're essentially saying that example 1, or we're not saying, we're testing if example 1 is equal to example 2 and example 1 is equal to example 3. Now, just to make more sense of these statements later on, can actually do something like this. They're really, you can think of them as in parentheses together, because that would essentially break down to, if we wanted to break it down on our own, example 1 equals example 2. We know that's going to be true. I'm just writing in an example. True. Or first, let's actually comment that. If you want to comment anything within your code, all you do, add a hash mark in front of it, and then you can type, and that code will not be executed. Another easy way to do that, you can do triple exclamation marks for a longer comment, which is really what we're going to be doing now. So we know that example 1 equals example 2. We know that is true. We already know that because they're both the same thing. I can explain it again for the other one. Example 1 equals example 3. We know that is false. Now if we do full statement breakdown, it's essentially true and false. Now, whenever you're using the and, they have to both be true in order for it to return true. If they're not both true, it's going to return false. So let's just show that. Okay, I didn't do our comment correctly, so let's just ignore that for now. That's just because it's not running, it's really running. Or actually, here's what we'll do. The Collab can be a little finicky sometimes in that this is really what we're running, but we're not doing it as a print statement. So it's trying to look at whatever was last or what can be run. It's in parentheses, so it's just kind of messing it up. To fix that, let's just set this full statement equal to something. Let's say full and result, actually we can say, and result equals, so it's basically equal to this whole entire expression. And then we're going to print and result. False. We expected that. That's exactly what we thought. Now let's talk about the and where it would be true. We would just do something like and result equals example 1 equals example 2. And example 1, let's say it does not equal example 3. We know that this statement is now true. This is still true, and now that this is a not, this will be true. And since we have true and true, we're going to get true for our result. There we go. Simple enough, I think. Now just talk about the ors briefly before moving on. What if we said, let's just copy this, or, we can change that back to equals. What that's essentially doing, we can do our little breakdown again. No, example 1 equals example 2. We know that's true. And we know that example 1 equals example 3 is false. So it's false. So we have it's true. This part's true. And this part's false. Let's change that to or. Now when one thing's true and one thing's false, or let's say you had another, let's keep adding on to our example. Example 1, let's just say does not equal example 2. So let's add that in here. Example 1 does not equal example 2. We know that is false because they are equal. So the full statement would be true or false or false. But since we use the ors, only one thing needs to be true for the whole expression to be true. Let's see that. True. See? And even if, let's say, 2 of them were true, 1 were false, it would still be true. Said all 3 of them were true, it would still be true. But if they were all false, then, of course, it would be false. We can also include and statements within this. Just copy that for... So let's change this last or to an and, just so you can see how you can use multiple in one. So these are still going to be the same, true, false, false. It's instead of or, it's and. So we really want to break that down even more if we can. We can go down and we say, okay, true or false, okay? We know that with or, as long as one of them's true, it's okay. So we're all good there. And then we also see and, or let's first say, first block, so true or false, we know that that's equal to true. And then we just, okay, we have false. So now our full statement, more broken down, is true and false. And we know that when you have a true and a false, that's equal to false. So we should expect to get false here. Oh, no, we didn't. But that brings us to an important reminder. We have to use basically order of operations in parentheses to dictate this. We want to say that these are together by just adding parentheses around them. So this is essentially one statement. And if you want to break it down, you just get what's in here. Okay, true. Example 1 equals example 3. You know that's false. So it's true or false, just like we did here. True or false is true. True and false is equal to false. There you go. We have it. All right, this video is getting a little long, so I think I'll stop it here. But in the next video, we're going to be talking about lists, dictionaries, conditionals, loops, all of that, and maybe even functions, but we'll see if we'll have time for the functions. So I hope you guys stick around and enjoy this new playlist.